Hi, everyone. We're group 7, and my name is Tiffany, and your group are Alex and Rafael. And I'm gonna explain the simple question number 50. So in this problem, we have 4 classes of insured, and each of them has 0 or 1 claims, and those are the probability that the claims can occur. And the classes are selected at random, so each of them has probability of 0.25. And 4 insurers are selected at random from each class, and the total number of claims is 2. So the problem is asking if 5 insurers are selected at random from the same class, we want to estimate the total number of claims using Bowman-Straub probability. Okay, so we're given 4 classes, and the X bar is the probability of each class times the number of claims, which is 1/2. And we're looking for 5 mu. So we start with the mean of each class, which is the probability of having 0 claims times 0, and 1 times the probability of having one claims, which is 0.1. And so we just repeat the formula for each class. And sigma square of class 1 is just the variance of class 1, and you just do the square of each claim times probability minus the mean, which is 0.09, and then you repeat what you did. Okay, so moving on to mu, which is the mean of the entire population, which is the weighted average of every class, and you'll get 0.425. And the variance of hypothetical mean just weighted average of the mu, and you'll get 0.096875. And then the expected process variance is the weighted average of the sigma square, the variance right there, and it will just be 0.1475. And then K will equal to EPV divided by VHM, which you'll get 1.52258. And then Z is the number of class, number of exposure divided by M plus K, and you'll get 0.7243. And then mu hat is just the Bowman-Straub credibility. It's gonna be X bar times the Z and plus 1 minus Z, and you'll get 0.4793. And given that we're looking for 5 mu, so we just times 5, it'll get 2.3966, which is answer choice C.
Okay, hey guys, my name is Alex Lin, and I'm going to do this problem from you. This is sample 50.1 from the 14th edition ASM C4 study manual by Abraham Weishaus. Okay, so the problem is for a portfolio of insurance risks, aggregate losses per year per exposure follow a normal distribution with mean of theta and variance of 1 million. Theta varies by class as indicated by the following table. Here's the table of the classes. Here you have your mean aggregate loss per year per exposure right here, and your percentage of business in the class. Since this is a Bowman-Straub problem, you also have your exposures down here, followed by the year. And the exposures are randomly from a randomly selected risk, and this is like basically his 3-year experience right here. And for each year you have this aggregate loss over here for every the sum of all the exposures. Let me remind you before I continue with this problem that the 3 numbers when you're dealing with Bowman-Straub analysis or credibility, you have V, which is your expected value of the process variance. You have A, which is your variance of the hypothetical means, and you have mu, which is your hypothetical means. And you use all of these guys to calculate K, which is your Bowman-Straub K, and then to calculate Z, which is your Bowman-Straub Z, and use these guys to get this final piece of C, or mu hat, which is your Bowman credibility estimate. Alright guys, I'm going to show you how to calculate this Bowman-Strauss, credibility, expectation. But first we have to calculate a whole slew of different numbers first. It's going to be breathful, so hang tight and I'll show you how to do it. Okay, so the first thing you have to do, judging from those two charts, I hope you guys have those down, is you have to find the exposure unit, okay? And the exposure unit in this case will be exposure year. And in order to calculate that, you add up all the exposures for the 3 years that you had. So N would be equal to, the exposures were 12, 15, 13. So you add those all up, the sum of all these, I guess. And that's equal to 40. Cool? So then you have to find X bar, right? So X bar is essentially the aggregate losses, the sum of all the aggregate losses, divided by the total exposure units, right? So the aggregate losses from, again, the last whiteboard slide would be 12,000, 18,000, and 14,000. Divide all of this by 40, and you get this magical number of, I'm due to my head, 1,100. Okay, so 1,100 is your X bar. The next thing you want to find is your mu, okay? So you're doing all of these, remember, to calculate this expected, like, Bowman credibility. So to find the mu, you find the, essentially what you do is you find the expected value of all the claims with respect to theta. Okay, and remember there was like 3 classes of claims in the previous whiteboard slide. So that's really easy. You just multiply them by their weight and add it together. The 3 claims, the mean losses for each claim was 1,000 for A, and that was 70% of the business, plus 1,500 for B, and that was 20% of the business, plus 2,000 for C, that is 10% of the business. And when you add these all up and do it, you should get 1,200. Cool. Okay, so here's your mu right here. And here's your X bar right here. The next thing you need to find is your VHM, or your variance of your hypothetical means. This could prove to be pretty tricky, but luckily we have a handy dandy formula sheet over here. So essentially what this is, it's your variance of your thetas, okay? And if you remember your thetas, you had this like table of thetas, again, you know, refer to the last whiteboard slide. And what you can do is you can bust out a little Bernoulli method right here. 0.7 times 1,000 minus 1,200, bending over backwards right now literally, plus 0.2 times 1,500 minus 1,200 squared, plus 0.1 times 2,000 minus 100 squared. And this is just a formula for like calculating your variance essentially. You know, you have your x of I minus your x bar, right, squared, multiplied by the weight of that specific x of I, okay? And your A, which is your, again, VHM, variance of hypothetical means, will be equal to 110,000. There we go. Okay, so we have all these numbers. We have mu, we have variance of hypothetical mean. Oh yeah, one more thing we need. We need V. And you get V from, you notice that the claims were distributed normally, right? So it was normal with the parameters mu as the mean and 1 million as the variance. Well, this right here actually is the expected value of process variance. Since it's constant, it's just, that's what it is. So this is your V right here, right? So you have V, you have A, and you have mu, and you have X bar, and you have N. You have all these magical numbers in order to find Z. Okay, and Z is essentially what you want to get in order to calculate PC. So we calculated all these numbers right here on the last slide. Now all we have to do is calculate Z using these properties right here. Here's the 3 equalities for Z. So you have NA over NA plus V, which is my personal favorite. The purists like to do N over N plus K. That's actually equal to A times A over N plus K. See, you do this so you don't have to calculate K, but either way it works. So K is equal to V over A, by the way. That's from the last credibility lecture. So let's find Z. All right. So Z right now, your N is equal to 40, right? Because that's all of your exposure units added up. So you have 40A over 40A plus V. Right, so you know our V is equal to 1 million, right? We know our A is equal to 110,000, right? So when you add all, you stick it in and you add it up, algebra 1, you get 0.8148, and that is your Z. And you use this magical number right here, this Z right here, to calculate P sub C, okay? And this is actually equal to the Bowman-Strauss credibility expectation, right? So finishing up, we have P sub Z is equal to, we have mu, so it is a 1200 plus Z times X bar minus mu, right? So you have all of these variables right here that we calculated in the last few slides, and all you have to do is plug it in, right? So you have 1200 plus Z, which is right here, you know, Z times X bar, which is 1100, minus, minus mu, which is 1200, and you get your expected credibility to be 1118. That is with 3 ones, 0.52. That is your PC, and that is the answer right here.